Ever tapped pay twice because the screen froze and then panicked that you'd be charged twice? Welcome to Data Explained, Episode 8. Today, we're unpacking idempotency, the quiet little principle that makes sure doing something twice gives you the exact same result as doing it once. It's the safety net behind almost every reliable system you use. So let's slow down and look at what actually goes wrong. You tap pay, the server does its job and charges your card, but somewhere on the way back, the confirmation gets lost. Your app, sitting there waiting, assumes nothing happened and quietly retries. The charge fires again. Now, what if the server could simply recognize, wait, I've already handled this exact request, and shrug off the duplicate? That recognition, that's idempotency. So here's the definition, stripped down to its essence. An operation is idempotent if running it once or running it 10 times lands you in the exact same place. No extra side effects, no surprise charges, no duplicated routes. Three things fall out of that. The end state stays the same no matter how many times you repeat it. Retries become safe by default, and accidental duplicates simply can't sneak through. To make that concrete, picture an elevator button. You press it once, the elevator's on its way. You press it 5 more times out of impatience. Same elevator, same trip, nothing extra happens. Now contrast that with a vending machine. Every press of buy costs you another coin. Idempotent operations are the calm elevator, not the greedy vending machine. And that's exactly the behavior we want when a request gets retried. So let's put operations side by side and see which ones pass the test. On the left, setting a balance directly to 100, deleting user 42, marking a status as paid. Run them once, run them 10 times, the end state never changes. On the right, adding 100 to a balance, inserting a new order, charging a card, each repeat stacks up another effect. Same intent, very different outcomes when a retry sneaks in. Here's the nice part. You don't have to memorize this from scratch because HTTP already tells you. Get just reads so nothing changes. Put replaces a resource with an exact state. Call it 10 times. Same result. Delete removes it, and gone stays gone. Post is the odd one out. Every call creates something new, which is exactly why it's not idempotent. That putty versus post distinction. Classic interview question, and now you know the real answer. So, how do we make post behave? With a little help from the client. The idea is simple. Before sending the request, the client generates a unique key for that specific action, say this exact payment, and attaches it as an idempotency key header. The server stores the result against that key. If the same request shows up again because of a retry or a flaky network, the server recognizes the key, returns the saved response, and crucially, doesn't charge the card a second time. Let's trace what actually happens on the server side. A request comes in carrying that idempotency key, and the very first thing the server does is check, have I seen this key before? If yes, it just hands back the stored response. No double charge, no duplicate insert. If it's new, the server does the real work, saves the result against that key, and returns it. These keys typically live in a fast store like Redis, with a TTL of around 24 hours, the same tool we covered in the caching video. So where does this pattern really earn its keep? Payments are the obvious one. Nobody wants to charge a customer twice for the same coffee. But it's just as critical with retries after a timeout, with message queues that promise at least once delivery and therefore guarantee duplicates, and with webhooks, where providers will keep resending until you acknowledge. Honestly, anywhere a request might arrive more than once, which on a real network is pretty much everywhere. And speaking of message queues, that's worth a closer look, because it ties directly back to our earlier video on the topic. Most queues deliver at least once, which means duplicates aren't a glitch you can engineer away. They're baked into the contract of distributed systems. So instead of fighting the inevitable, you shift your goal. You stop trying to prevent the duplicate from arriving, and you make sure that when it does, processing it a second time produces the exact same result. That's idempotency doing its quiet, essential work. So how do you actually build that quiet, essential work into your code? There are a handful of go-to techniques. You can use an idempotency key, a unique token the client sends so the server can recognize a retry and dedupe it, or lean on a natural unique ID, like an order ID, and let the database reject duplicates outright. You can upsert instead of insert, so the same operation always converges to one row. Or simply check then act, ask already paid, before doing the work again. Now, there's a subtle distinction worth pinning down. Idempotent doesn't mean the same thing as safe. A safe method, like a JET, changes nothing at all. It's pure read-only, no side effects whatsoever. An idempotent method can change state. A delete actually removes something, but repeating it does nothing further. So safe is always idempotent, but idempotent isn't always safe. There are side effects. They just happen exactly once. And while we're drawing distinctions, let's clear up a few myths that trip people up. Idempotent doesn't mean the response is identical. A first delete might return 200, the next a 404, and that's fine. What matters is the end state. It also doesn't prevent duplicate requests from arriving. It just makes them harmless when they do. And no, get and post aren't interchangeable. Get is safe and idempotent. Post is neither, and swapping them quietly breaks the web. So how do you actually do this well in practice? On payments and anything that moves money, always attach an idempotency key. Give those keys a sensible time to live so your storage doesn't balloon forever, and make sure your consumers can safely rerun the same message. On the flip side, never assume the network is reliable. Avoid read, modify, write updates like balance plus amount. Don't recycle a key across different actions, and don't let keys live forever. And here's the thing. You've almost certainly relied on this pattern without realizing it. Stripe, PayPal, and Adyen all expose an idempotency key header on payments. AWS bakes a client token into its APIs for safe retries. Kafka has idempotent producers. HTTP itself gives you get, put, and delete semantics you can lean on. And every webhook sender out there is quietly rescinding until it gets a 200 OK. This idea is everywhere once you start looking. So let's pull the key ideas together. Idempotent simply means doing something once or 100 times lands you in the exact same end state. It makes retries and duplicates safe, not impossible. Get, put, and delete give you that guarantee for free. Post doesn't, which is why idempotency keys exist to make it safe to retry. And whenever you're touching payments, queues, or webhooks, this isn't optional. It's the safety net holding the whole thing up. Here's the quick gut check you can run on any endpoint you write. Just ask yourself, if this exact request fired twice by accident, would anything actually go wrong? If the answer is no, same result either way, you're already idempotent and retries are safe. If the answer is yes, it would duplicate. That's your cue to add an idempotency key or a unique constraint before it bites you in production. Now, idempotency is just one piece of the reliability puzzle. If you want to go deeper, the Data Explained series covers the neighbors you'll keep bumping into: ACID and sharding, caching and queues, rate limiting, and more. Pair those with solid transactions and retry logic, and you've got the full toolkit for building systems that don't break under pressure. So, here's a quick one for you. Have you ever been double charged by a flaky checkout? That's almost always a missing idempotency key in action. I'd love to hear your story. Have you built these safeguards into your own APIs, or did you learn the hard way after a production incident? Drop a comment below and let me know. And that's idempotency, your safety net for reliable systems, all wrapped up in one simple key. If this finally made the concept click, hit subscribe and stick around for the rest of the Data Explained series, where we break down one tricky idea at a time. You can find more over at Dargslan.com. Thanks for watching, and I'll see you in the next one.